Well, I probably would if I'm well. So okay, so I'm going to click next on my console app. Let's just call this I don't know, day two, because we don't know really where we're going. So um, we'll just put a generic name on it, or and we'll create that. Yeah, actually, that makes sense. Is like there are places like Flickr and places like that. I guess people could have people post their photos on their own space. Well, problem there is that if they go away, if their space goes away, then we lose the photos. So we, yeah, yeah. Mine's still spinning. Oh, there it went. Whenever I'm like doing video and stuff, sometimes it slows down. Okay, so let's see, namespace, class program, console write line. I do have a C# program. Hit Control F5, make sure it's running. And so last time what we did is we wrote some output, we got some input, we did a calculation, and then we displayed a result, correct? And how did that feel? Did that make a lot of sense? Do we need to go over that a lot more, or can we move on a little bit? Well, darn, that throws my whole lesson plan out the window. No, just kidding. um, ah, yes, absolutely. So we used console dot write line. There's also console dot write. So let's say that we wanted to enter a number. We could do console dot. Let's say we're going to input an integer and num times. So we're going to do a loop after this. And we're going to say console. Now, instead of write line, I'm going to say write number of times. And then I'm going to say num times is equal to int.parse, because we're going to convert whatever we get into an int. And then we'll do a read line. And then I'm going to, just initially, we're going to console dot write line. You entered plus num times. So here we're bringing in the we're going to output whatever we got just to test what we did. So I'm going to hit Control F5 on that, and see what I get. If I put 5, you can see you entered 5. Does that make sense? And you see now it's going right next to it. So right won't put the carriage return automatically at the end. Right and right line. Now, so the next thing we're going to look at is a loop. You know, let's say we wanted to say hello world. We got this one here. I'm going to just reuse this. Move it down here. We want to say it 5 times. We could do this, right? But the problem is, let's say that we wanted to do that as many times as the user entered it. You know, so the problem with this approach is 2 things. One, if I want to do it 100 times, I got to hit Control V 100 times. And if I wanted to let the user control how many times we do this, then that would also be kind of problematic. You know, I'd have to rewrite the program every time the user, you know, wanted to do something. So we're going to look at something called a for loop. And the way this works is I'm going to create I, and then we use the letter I for index. And we start off, we're going to say I is going to start with the 0. And so this for loop has 3 parts. First is initialization of a counter variable, which in our counter variable is I. And then we're going to say, well, I is less than, and I'm going to hard code this for now, 5. It's going to keep running this loop. And after each loop, what we're going to do is increment I. And we have this shortcut, which is plus plus I. You could also do this by saying I is equal to I plus 1. Just make a statement that way. But because we do this a lot, we have a shortcut number which just says plus plus I. And then in curly braces, we put the code that we want to have executed in this loop. So this loop will start off with I equal to 0. It'll check to see if I is less than 5. 0 is less than 5. It'll execute this console write line. It'll come back around, increment I by 1, so I will now become 1. See that 1 is less than 5. Do this again, and just keep looping through until I reaches a condition where it is no longer less than 5. So once I hits the value 5, it'll stop, and we'll just to make sure that we know that it got to the end of our loop, we'll put in a write line that says, "Thank you for using my program." So right now we're not using num times in this at all. We're just running it 5 times. But I wanted to show you how a hard-coded one where we hard-code the number is. And if I run that, it doesn't matter. I can put like that many. Right now you can see it actually ran this hello world 5 times. Does that make sense? So there's a way we can actually watch this happen. What we can do is we can put, you see this gray bar to the left? This gray bar right here is where we can put a stop point. So I'm going to click inside of this right next to the beginning of this for loop. And rather than, right now we've been running with Control F5, which is start without debugging. I'm going to run it in debug mode with F5. So I'm going to hit debug mode with F5, and then what's going to happen is when you run in debug mode, it'll bring up the console, and I'm going to move that to the right and move my code to the left so that they're side by side. I can see both. Give it a second. It's kind of thinking. And so now I can see my code here, it's going to run through this part here in debug mode because it's going to run until it gets to the stop. So I'm going to put in, whatever. We didn't really do anything with this yet. And now you notice that when it gets to the stop point, you get this yellow arrow, and it's sitting on the next line to execute, which is setting I equal to 0. The other thing I want you to do is go down to where there's output, and you click on locals. If you don't see that, you can go to view and look. Let's see, where do they put it? It's one of these. Oh, under other windows, you should, this is where some of these live. So this locals ones is, it's somewhere here. I always have a hard time finding where they store it. It's usually always open for me. Data, cloud. Oh, I remember. It's actually under debug to find that window. Under debug, you have autos, locals, and watch. So if you don't have this up there, just go to the debug window and make sure that that window is available. So does everyone have this locals window open? Debug. Do you have That's what you want. Click on locals. This should bring up a window. Yours is a little different because you're on a Mac, but I think it has the same capabilities. So the reason why we want this locals window is it shows us what the current values are. And you can see here where we set 0 into I. The other way that you can do it, which you might try, is if I hover my mouse over I can see what its current value is. It's really small probably on your screen looking at mine, but if you hover over it, you'll see that it says I is 0. Does the hover work? Good. Perfect. And then down here, you should have like something that shows you what the actual values of that variable is. So if you hover anywhere where it says I, it's actually showing you not what the value is at that point where you're pointing at the code. It's showing you what the value is right now where this yellow line, this yellow arrow is in execution. So right now, I starts off as 0. Because we've done this assignment. Now, what we want to do is if you go to your debug window, you'll notice that there's a bunch of commands. One is continue, one is stop. We don't want to hit those. The one we're looking for is F10, which is step over. And rather than clicking on that, I'm going to look at the shortcut key. And then I'm going to use the shortcut key which in my case is F10. It might be something else on the Mac. So there's also these buttons up here which are convenient. So I'm going to use these buttons. Every time you click step over, it'll show you where it goes next. So right now it's done the comparison to see if I is less than 5, and that returns true. So then it will do this block of code. Anytime we have curly braces, we call it a block of code, and this block of code belongs to this for loop. So when I click step over, you're going to see that it does the console.writeLine. It does that one. I is currently 0. And if I step over again, and you can see here that it actually printed out the first hello world. We're now here, and we notice that what's highlighted. This isn't highlighted. What's highlighted is plus plus I. So we can see down here that I is currently 0. When I hit the step over one time, I now becomes 1 because it added 1 to it. In your locals window, when something changes, it'll initially highlight it as red, and then it becomes black on the next step over. So I do the step over again. 1 was less than 5 still, so it does another console.writeLine. I step over the console, and I get my second hello world prints out. I'll now step over again. Now we're back at this plus plus I. I start is currently at 1. When I step over that, I now becomes 2. You can see it down here. I can see it if I hover over here. And if I hover over the less than symbol, I less than 5 is still true. So it's going to do another console. Does that make sense, kind of what's going on? And so I get my third hello world, and I'm going to step over. I now becomes 3. 3 is less than 5. Get another hello world. I now gets incremented to 4. 4 is less than 5. And now I have my 5th hello world. So it's currently 4. Why do I have 5 hello worlds? Where do we start? Yes, and the key here is that I started at 0. So this first one was printed with I equal to 0. The second one was printed with I equal to 1. The third one was printed with I equals to 3, or to 2, 3, then 4. So now we're on 4. Now what's going to happen is I'm going to step over. I gets incremented with this step. It's now 5. Is 5 less than 5? But it's not less, 5 is not less than 5, correct? So this is now no longer true. Because this part is now no longer true, it will not do another iteration. It'll skip over the console writing line and continue with the next line of code, which is at line 21. Does that make sense? So you see kind of how, so basically we start at a value, we have a change condition, and then we check to see if it's met some termination condition. So now we're down here. We're at the thank you for using my program. When I step over that, we now get thank you for using my program. So that's called a for loop. The for loop makes sense when we know how many times we want to run. Now, that may even means if we get the number of times from the user, when we get to this for loop, we know how many times we want to run. So how can I change this code so that I use what I got from the user? What could I change that 5 to? Well, that would be hard-coded, but here we see what we did is we declared an integer called numTimes. We asked the user how many times they would want to do it, and we stored it in this integer called numTimes. Could we use that in here in order to make it so that we would run this loop the number of times the user told us to? We can, because what we can do is, this number here is an integer. It's what we call a literal. In other words, we've just hard-coded that in there. We've typed a number in. This is a literal. But we can also take a variable and put a variable anywhere that you have a literal. As long as this is the right type, which for this for loop, it requires an integer. So I'm going to stop debugging, which I can hit the stop debugging button here. Or if you go to debug, there's a stop. And then I'm going to rerun this. I'm going to hit Control F5 initially just to show you what this does. And then we'll step through it. And if I say 3, I get 3 hello worlds. Run it again. And if I say 4, I get 4 hello worlds. Does that make sense? So this is this is where it starts getting kind of complex with working with code, because it's like a big set of Legos. We can plug and move things around. And in this case, we took a literal number 5, rather than hard-coding it, we use this variable, and we're going to ask the user for how many times they want it. We're going to store what they asked for into this integer, and then we're going to use that integer in this piece of code. So let's see what that looks like when we run it. So I'm going to move my stop point up to 11, if it'll let me. I don't know why it won't let me stop before that, but oh, there we go. So I'll go to here, and I'm going to run in debug mode. Move these so that we can see both the console and where I'm at. And if we look at this, right now we can see num times has been declared and has a value of 0. I'm going to step over and the line we're currently on is on this right. So I'm going to step over that, and the right happens. And now we're sitting here over this read line. I'm going to step over one more time to get this read line to start executing. I know that I'm in the read line now because the cursor is blinking on my console. I'm going to put in the value 3 and hit enter. I can now see that 3, the num times, has been updated to the value 3. I'm going to do this console.write line. It says you entered 3. So, okay, we confirmed that we got what we entered. And now we're sitting here at our loop. I just got declared. We can see it has a value of 0. I'm going to step over one time, and we're now sitting at this comparison operation. And it's basically asking, is I less than num times? Well, what's I? I is 0. What's num times? Currently, it's 3, the value that we entered. Is I less than 3? So is 0 less than 3? Yep. So 0 is less than 3. I'm going to step over, and where's the execution going to go next? Correct. So this is kind of, the pattern is basically it comes into this first part of the for loop. It does the comparison, then it does the block of code, then it goes over to the plus plus I, then it goes back, and then it just ends up becoming this counterclockwise loop through here where it's doing a comparison, doing the block of code, incrementing, compare, block of code, incrementing. So you can think of it as it comes in here, goes through here, and then it just goes in a loop this way. So I'm going to step over. It does the block of code, writes the hello world, and now it's at plus plus I. I gets incremented, is now 1. Is 1 less than num times? Num times is 3, so is 1 less than 3? Yes. So now it goes, and since that's true, it'll do another iteration of the block of code. Increment I. I is now 2. Num times is 3. Is 2 less than 3? Yeah, that's true. So we're going to do another block of code. I becomes now 3. Is 3 less than 3? Yeah. So in this case, it's not going to do the block of code. It's going to say, I'm done with the loop. It's now to thank you for using my program. We do that, and we're done. Notice something, how this ends up working. So notice it doesn't do the last one with less than 3, but that's okay because it started off at 0. So when we put num times here as 3, it will actually do 3 hello worlds. It's just going to go 0, 1, 2, and then be done. To kind of show what this looks like, I'm going to add iteration plus I so we can see which iteration we're on. And then I'm going to run this again. So again, I'm at my read line. I do my read line. I enter 3. I'm now going to write out how many I entered. I'm now in my loop. I starts off as 0. Our condition is I is less than 3. I is 0. 0 is certainly less than 3. We're going to write out hello world and iteration 0. So now we can see what I is. Come around, increment I. I is now 1. 1 is less than 3. Now prints out 1. I gets incremented to 2. 2 is less than 3. So we print out iteration 2. We increment I. And I is now 3. So it looks and sees if 3 is less than 3. Certainly isn't, and we're done. Make sense? It can be any variable using a legal variable name. So I'm going to change this to count to demonstrate that. So count's a legal variable name, and it will work the same. I'm not doing it in debug mode, but it shows you that it does the same thing. Oop. I hit a key. Yes, I'm going to switch back to I because it's a little bit more succinct. We can actually reuse that variable, and the reason is because of something called scope. So this variable I only actually exists inside of this for loop. It doesn't exist outside of it at all. So anything defined inside of curly braces only exists in those curly braces. And so with a for loop, you can treat it as if I was defined inside of this curly brace, this block of code. So here I'm using it again, and if I were to run that, and then I could say, you know, I'll just display I, and we can see that both of these ran. It used I twice. But because they're in separate scopes, it's okay to reuse the same variable. Does we'll revisit that if necessary a little bit later, but this scope thing is kind of done in order to save memory. So anything that's declared in here, so I could maybe make a string here. String text is equal to hello world. And I could actually say I could have a string that has hello world. And then I'm going to concatenate in this string. And then over here I could have another string called text. And effectively, go ahead. What belongs where? Yeah. Yeah. So, you know, in this instance, it's going to look exactly the same. It's just that I used variables, and it is okay to redefine it. Now, where this would not work is if I took this one and I defined it here. So ordinarily that would work fine, but you'll notice that now we have a problem in the text that's down here. It says a local parameter named text cannot be declared in this scope because that name is used in an enclosing local scope to define a local or parameter. So pretty clear English, right? More like the retro encabulator thing. So what this is really saying is, hey, I already have a text in memory. I can't make another one because this one being outside of these curly braces is actually defined within the scope of this function called mains curly brace, within mains block of code. And so if I declare it out here, I can't declare this one because this one has visibility on that one. Does that make sense? Now what I could do is I could just do that. Is I am redefining text before I print this out. So now I'm using the same memory space, I'm just assigning it a different string, and it would work. And it's okay if that's a little confusing at this point. We're only on day 2. But does that kind of make sense? So where you're going to see scope issues is when you see that error that basically says, hey, I can't redefine this. So we'll usually have the word redefine in it. In fact, if you look at that error, oh, sorry, that's string. Or you'll see this word scope show up and it says, I can't declare that because it's used in an enclosing scope. When you see that, what you should be thinking is, oh, I've defined this already somewhere and I've used the same identifier. So either I can use that existing one that's already been declared, or I need to change the name. So I could also do string text2, for example, and that would be a different variable. So then this would be okay if I use a different variable name. What this leads to is using good variable names that are meaningful is important. So in this case, really kind of the mistake we're making is, hey, this isn't well defined. Maybe maybe I want a name more like that. And then the structure's kind of off. If I'm going to be doing work with this here, I probably want to work with it in the same scope. So I would, change my preamble to equals I colon and then to create some better symmetry, what I might do is I might do this. I might say, hey, why are we like breaking that up? Let's just do this. And now these look much more alike. The only difference is, I'm changing the preamble before I do the next print. Does that make sense? And you'll be kind of like in any given program, this is kind of thing you kind of like, we saw like 4 or 5 different ways of doing this. They are all will function, but there's different ways of do I put this in a variable? Do I use a literal? Do I, what order do I do things? Do I want to do things inside of the scope or outside the scope? Those can be different right answers. So sometimes that's style, sometimes that's efficiency. We're noticing now this is almost an exact replication right here. We're going to, and keep that in mind when we go talk about functions later on, because it seems weird that we're doing the same thing, but we're having to write it twice. As programmers, you're going to learn to hate that kind of repetition. And we're going to learn how to avoid that later. So that's the for loop. Let's look at, so any questions on the for loop? So we're going to look at another kind of loop, and it's called a while loop. And if you want to, you can start a new project, or you can copy paste that off to a new text box. Probably, let me let you keep that. I'm going to go ahead and start a new project because I think it's probably easier for you if we put these in separate projects when we're starting off new stuff. So I'm going to make a new console app, .NET Core, and I'm going to let's call this while demo. And so we're going to do this. we want to keep counting until the user says stop. So we're going to start off by building the keep doing something until we stop. Well, actually, no, we'll start with the count. So I'm going to declare an integer called count and initialize it to 0. And then we're going to do a while loop. And the way a while loop works is like this. We say while count is less than, or we need some condition. And so the condition is we're going to create a string so we're going to say while user input, we're going to set user input equal to y. We're going to say while user input equals y, we're going to plus I, or plus the count, and then we're going to console output the count. So we're going to create a counter, set it to 0, set a string to y, and then while the user input equals y, we're going to increment our counter, and then we're going to write out what the result, what the current value of count is, ask if the user wants to do another, and then we're going to loop around. This is called a while loop. And you notice that all these loops depend on a Boolean expression or a logical expression that returns true or false. So in the for loop, we had, I less than some value. Here, we're using user input. As long as it equals y, we're going to keep going until the user says it's not y. So go ahead and make that and then run it. And every time now I say y, it'll keep incrementing count until I say no, and then it stops. Let me know if that worked.
I've got something going on. Computer stuff.
Notice that this is also a double equals. When we want to do the logical expression for equality, we use double equals. When we want to do an assignment, we use a single equals.
Yeah, well, that'll do it. It's a good, it's a good, really? Oh, I mean, it's a pretty good episode about puzzles.
Weird things happen if you make a logical expression and use the single equals instead. So let me know if that works.
I got some more work done on the sidewalls today.
Yeah. Yes, absolutely. So there's a trick that we can do with that. Yes. So we could actually say, hey, I'm going to take the first element and we put single quotes. Single quotes mean a character. So now with single quotes, you can only put a single letter in here. This says, hey, if the first letter of user input, the first element of the one index 0, if that equals y, then so I can put y, I can put yes, and I can put yabba dabba do, and anything that starts with y will work. Hello, Megan. Oh. So you got the so you're on the same machine now as the Mac. So what we're working on now is this is using a while loop, and the way the while loop works is it's actually a little bit more straightforward almost than the for loop because there's only one thing in here. It's just a logical expression. And I'm going to go back to where it was before, so it's not quite so confusing. So what we're doing is we're going to create two variables, a count variable and a string variable. We're going to start the string variable as y, and then we're going to increment the count each time we go through this loop and display its result. And then we're going to ask the user if they want to do another. And if that is y, if they type in y, it'll keep looping until they type something other than y. So the way the while loop works is basically it evaluates this logical expression every time it comes around. If that is true, it will do another iteration of this block of code and then reevaluate it. So for both of you, the key to a while loop is that something has to be able to happen inside of this to make this expression eventually be false. Otherwise, you end up with an infinite loop. So go ahead and type that one in and see if it works.
The one that investigates house owners is yeah. But the British version apparently is DC. So you have to show that for long pieces. That's why British show. Yeah.
So the key difference between this for loop and this while loop is that the for loop, you kind of have to know exactly how many times it's going to execute beforehand. You could do some weird things to kind of make it, not do that, but that's not the primary purpose of a for loop. So if you find yourself really working hard with the for loop to change its, you're messing around with its loop variable a lot to make it do stuff, you're probably not using the right structure. The while loop can execute an indeterminate number of times. So, this could keep executing, for an hour if someone hits Y all the time, or it could execute like 1 or 2 times if they hit no, very quickly. So for loops are used when you know how many times you're going to execute, or even if you're like asking the user for an input like we showed, when you get to the loop, there's a specific number of times you're going to execute. That's where a for loop gets executed. A while loop is you're going to figure out when you stop inside of the block of code. Some condition is going to happen that you're going to look for to make it stop. Does that kind of make sense?
I've got squash blossoms. Yeah, at this point, I might actually get something out of it.
So,
that might be the whole. I have like there's still a.
Let's see, what could we could do with this that would make it that would illustrate more the use of the while loop in this structure. We could ask maybe. Oh well, I'll wait till you get done with this example.
Yeah. Rob found out that Total Wine at warehouse, they do curbside service. Rob got half a dozen bottle of wine he was able to order on their website, and you have to walk up to the door and they hand over the bottle of wine. Yeah. Mm-hmm.
Yeah, so right now we're learning loops. The next time we're going to learn if statements. And that's between if statements, loops, input and output, and calculations. We're going to find that we can actually do quite a bit. In fact, those pieces used to be pretty much what programming was. So we're going to play around with those a little bit. I thought maybe what would be cool is once we get to that level, is making a text-based adventure game. Does that sound interesting? Yes. Yeah. Yeah. I think that way we'll get into doing something kind of fun. As early as possible, because the more it gets, and then maybe what will happen is that will draw some of the things that we'll come up with something we want to be able to do, and then that will drag out. Okay, let's figure this piece out next, and then let's figure this piece out next. So I think that's where I want to head with this. Is we'll do a little text-based adventure game, and you can learn a lot with that structure. So let me know when you've got this one working, and then I'll go, and we'll go on to the next thing. Okay, no, we'll wait. I'd rather have us all moving simultaneously as much as possible.
Some other stuff, so yeah, but I didn't get my curtains either, It's coming up on our 25th wedding anniversary. I'm going to talk all about it, you know? Well, you know, I have to admit, the private show would be pretty isolated, you know, because it's open air. So, and technically, you know, you can, there's a shower right there, so, you know. We want that. Yeah, they have nice food there. So, yeah, that is true. That is true.
Yeah, Matu, you're talking about usage rights on images if people upload them. I think as long as I put the statement that, hey, only upload images that you've created, you know, at an SCA event. That would probably be okay. Then if I put in a review process so that it doesn't get posted, it doesn't become visible until someone's reviewed it.
Yeah. Yeah, I understand. They will have some fun for the further date.
Yeah.
Yeah. That should be fun. Yeah, I haven't, other than picking up the grocery order, I haven't done anything else this week, you know? Sorry. Sorry, I think I overheard maybe today, just like messed up my stomach. Talking to I tried a little bit of that. We got that into set TV yesterday. So, yeah, it's a little bit tired, but gotta give a place to sit. You know,
Hello?
it's out of my way. So,
I think, I think we lost Batu. Yeah, you're back on. But yeah, you're saying something interesting about you mentioned something about if it was on your page, then you felt like you had less of a consequence. But if it's on the official page, there's an issue.
Christine made comments. Yep, that's kind of how it works.
That's a good point. I'm going to look at the social media guides that are on the SCA.org website and then the webmaster guides and see if there's anything posted there about that. I'll bet they have an answer to that. But that makes sense. There probably should be they probably are going to require some kind of vetting or review, at least a cursory review, I would imagine. And that I'm thinking, as long as they have that process defined up at the org and we comply with it, I think it would be okay. If they don't define it, then I probably will send up a request for clarification. Hey, if we do this, what's needed? And they can either say don't do it at all, in which case okay, well that's kind of boring, or yeah, because it would be there's got to be a way of doing it. So I'll take a look. Yeah, that makes sense. I know that the crown training I came second in, there was a don't live stream rule on it. And I think the only one that went out was the final. It was me against Baylor on that one. Okay, cool. We'll continue on with that discussion later. We've got this. Let's see if we can make this a little different. Let's make this into an educational thing. So what we're going to do is we're going to modify this, and we're going to create an integer variable, and we're going to ask the user to do this. We're going to get the number from the user, and then loop until the user enters the square root of that number. So now this looks like this. We're going to say int num is equal to, well, first we're going to ask them console.writeLine, all right, please enter a number. Equals int.parse. So we'll get an integer. And so then we'll ask them, please enter the square of that. And we're going to loop as long as square does not equal. So we can we use exclamation point and equals for not equal. As long as it does not equal we're going to say math dot square root of num. So math dot square. So there's a bunch of math functions are available, and you can see if I hit a dot, I can list all of them. Your trigonometry functions, your logs, your cosines, all the fun stuff in math is there. And what we're going to do is if they don't get it, we're just going to ask them for another number. So this is called a priming read in the sense that we do one read to get started, and then in our while loop, we'll keep looping around until that's it. And maybe just to make sure they know what happened, we will make a nice gentle message that says wrong. And you can put anything else on you want it. And that way, we will make this a very aversive learning experience, and that will encourage people to learn. That's actually not the best way to teach people, but it's the easiest way to program it. That's how we learn SCA fighting.
There's no easy way to say this. This isn't going to work. I just know you're right. No one else. We can try to help you. Absolutely. We just want to do the job.
Let's stop that word. I don't give in to it.
I don't know. She moved her transfer. So I mean, it's
So one thing with errors is first look at the error list. And so, for example, if I say I did something like that, if you on your error list, if you double click on it, it'll take you straight to where the error is. And usually it'll be red squiggled. Hover over it and look at and then your variable, which in this case is num. Now, the other thing about the Visual Studio is it has something called IntelliSense. So if you hit dot and you start typing, when you are over the element that's there, sometimes what you can do is it's called tab completion. Notice how I've got SQRT highlighted. When I hit tab, it will actually write the rest out for me. And then as I'm typing in my variable, it'll highlight it. I recommend actually, even though I've got the whole thing typed, I'm still going to hit tab. And the reason is that if there's any capitalization or anything, it'll fix all the capitalization for me. And those just make you faster. I mean, when you first start programming, usually where you run into a lot of difficulty is in capitalization of identifiers and keeping everything lined up, that way. Yeah, and dot parse, and then one way you can check your parentheses, if you highlight one of the parentheses, usually, let me see. Yeah, if I put my cursor in front of this parentheses, notice that it highlights the closing one. So I can use that to verify my parentheses, make sure that the opening ones have a closing one. So if I put 9, the square of that would be 3. If I put in, let's say 4, it says wrong. And I put in 5, finally I guess 3, and then I got it. So what I could put at the end of this is console.writeLine. That yeah. Well, it's the other way around. So if you enter 4, then the answer would be 2. Square root. And so some of these actually you could get infinite loop with this because, if I put in like 3, I can't, or if I put in like, 3, I can't put in an integer that times itself will equal that. So I'm going to modify this. I'm going to change it to float. And if I really just need to change those 3 locations, and now it will deal with a floating point number. So theoretically, those 4 locations. So it probably would be better if this was floating point number. Okay, so this is called a prime. So did that work for everyone? Cool. So we're going to do one final thing with this tonight to give the last structure of a loop, which is this is a while loop, and you notice we had to do this priming read thing. So sometimes a while loop makes sense, but we're going to do this. We're going to take this while and we're going to put it at the end. And when we put it at the end, we have to put a semicolon here. I'm going to get rid of that. And then we're going to put the word do. So you probably heard of the word do loop at one point. You may have heard someone say that. But basically, a do while loop, is the same thing as a while loop, except that because the logical expression is coming at the end, when I do that, I can actually delete this first duplicate. And I'm going to get rid of this wrong statement now because it's not wrong initially. I still need my float square variable defined outside of here so that it's available. But now, notice that it really makes it shorter because I don't have to duplicate this code. And so this is actually a preferable way for this particular problem, because now I ask the user to enter a number, I get the number, I declare a variable for square, I get the user input for square, and then I check at the end, and so that makes more sense. If I run this, I put in 4, 3 is not it, 5 is not it, and 2 is it. And actually, this should be float.parse if I'm making all of these be floats. So the only changes there is just put the while at the end, leave the declaration of float at the top, and then we only have to ask for the square one time. Does that make sense? So these three loops are basically the only three loop styles that you have. Well, there's one more called for each. We'll look at that later on when we get into collections. But these are the primary a for loop, a while loop, and a do loop are the primary loops that you have in most computer languages. And with those, we can take care of anytime we want to do duplication. So loops are important because one of the things we want with computer programming is to do repetitive tasks. So you pick the right kind of loop for the repetitive task. And the key differentiators is if you know how many times you're going to execute it, you're going to do a for loop. If you don't know how many times, it's either going to be a while or a do loop. And the one you pick for a while, the way you pick between a while and a do loop is if the condition should be evaluated before you do the block of code, then you would use a while. If it should be evaluated after the first initiation of the block of code, then it should be a do loop. Make sense? So, what's that? Batu said something I missed. Oh. Okay, so I think that's enough for tonight. Did you both get that last piece to work? Okay. Oh yeah, good idea. I should have done that as well. And let me see if I can find some references for us. I'm going to put this in the chat. So those two links have the for loop and then the while and the do while loop. And they have a little bit of exercises and examples you can play around with. And it's W3 Schools, which I like. But they're good as a kind of a supporting website. They're good as a reference, I think, when you're learning. Cool. So you might look at those links I gave you between now and next time, and we'll play around with a few other things with loops, and then we'll move on to if-else statements. We also need to discuss, I think, logical expressions a little bit, and then so that should be good. So cool. Absolutely, my pleasure. See you all next time.